So moving forward, we can take an example of thermal and a photochemical condition. For the thermal condition, obviously Huckel will be applicable, allowed process with respect to 4n plus 2 pi, and with respect to 4n system, Mobius theory is applicable. It will form a cyclic transition state, which is clearly visual from the slide that we are presenting here, is that there is no gap or there is no breaking of the loop formation of the electrons. So it is a consideration for one of the simplest example from 2 plus 2 cycloaddition and 4 plus 2 cycloaddition, wherein we are clearly observing that given an ethene and an ethene is forming an 4-membered transition state like. Correct? And next case, if we consider an 1,3-butadiene with an ethene, it is clearly visible that the p orbitals are involved and there is a cyclic loop or a ring formation with respect to 1,3-butadiene and an ethene, giving me an 6-membered transition state. Hence, this clearly proves that it is applicable through perturbational molecular orbital theory to understand the molecular structure also, but by the impact of some changes that would be considered through thermal and photochemical condition. On the last case, we are having the correlation diagram. So nothing but we are considering the orbital correlation diagram. So in the orbital correlation diagram, till now whatever we did, it was purely consideration of the orbitals and their interactions either to the terminal orbital or from the terminal orbitals to other terminal orbitals in the same molecule or in the another molecule. So we are considering now the orbital correlation. So word is itself by very clear that we are no longer depending upon the single molecule to understand its orbital arrangement, but in fact we are going to relate it with another molecule also and try to build a diagram for that is referred to as correlation orbital diagram. Obviously in this case we are going to do it without symmetry and with symmetry. So for that we are supposed to learn through the conceptual understanding, and which will be broken down in the previous upcoming classes. So this is about the introductory part to the pericyclic reactions. Quickly, we can take up a glimpse and interactive session or the discussion among you. Thank you.